Purpose of this video is to explain the use of the up-LD or upstream linear distortion function in the Trilithic DSP meter. Some meters it's standard, some meters it's an option. Either way, to access this function, you simply go to the troubleshoot screen and select up-LD. Once you do that, it will log into the modem, so it may take a minute or so. But once it logs in, you'll come upon this display. Now what this is this takes advantage of the cable modem's pre-equalization functionality. So in order to see this display, that has to be active in the CMTS. If you go to this display and you don't see any of these bars, that's telling you that it's probably not active in the CMTS. The purpose of pre-equalization is to correct or actually distort the output of the modem so that it hits the CMTS at a very flat signal. So if for some reason the CMTS gets a distorted signal initially, it will tell the modem to distort its output so that the CMTS sees a better signal. So the first display are the equalizer taps. What equalizer taps are, they're actually time delay taps that are how the cable modem adjusts its output. You'll see here there's actually 24 bars in a DOCSIS 3 modem. The blue bar is the output of your modem, and in this case your meter. The bars 1 through 7 basically indicate upstream or plant issues. The ones from 9 on out indicate downstream. So the way this would show you a problem is this red line indicates the DOCSIS standard. So if any of these bars, other than the blue one, are above this line, that tells you you have an issue. Once again, 1 through 7 tend to indicate group delay, whereas 9 through 24 tend to indicate microreflections. So as you can see here, starting at the top level, this is the reference level, which you can change, and that basically just changes the top of the graph. There's a dB per division that you can also change, 5, 10, 2, and 1. And then there's the channel number. If you have 4 upstream channels, you can change it, 1, 2, 3, 4, and it'll give you the information about that channel. ID number, center frequency, level, symbol rate, and then you have 2 markers that you can use, your up and down arrows to move the markers, and you can place that marker on any of these bars if they're above this line. Now this time, if you calculate it with the velocity of propagation, can give you a distance to fault. In future firmware versions of this option, we'll actually give you the distance. Okay, now if you hit the display, you have two other options here. There's in-channel response. In-channel response is basically upstream flatness, but DOCSIS specs it in a 1 megahertz bandwidth. So once again, you have the reference level. Now the reference level here is calculated a little bit differently. This isn't the top of the graph. Plus 5 times 0.2 dB per division gives you 1. Channel is the same way. Now what you have here, you've got two markers, and if they're locked, they're 1 megahertz apart. So you can unlock it and move them anywhere you want to, or leave it locked at 1 megahertz apart, which is how DOCSIS specs in-channel response. So you've got the difference, you've got the two markers, and then you've got the peak to valley between the markers, which DOCSIS also specs at 0.5 dB within a 1 megahertz spacing. If you unlock them and move them to different positions and they're not 1 megahertz apart, then that's basically up to your company. Ripple is a measurement that some MOSs use that basically measures the amount of ripple between the markers. The next display is group delay. Group delay, once again, is measured in a 1 megahertz bandwidth. Group delay is time, not level. So basically, you've got a delay between the first marker and the second marker. So you've got, it's measured in nanoseconds. So right now, I'm in this channel, I'm at 24.52 and 25.52, and the difference between these two would be your group delay. Current DOCSIS spec on that is 200 nanoseconds. Basically, that's the upstream LD function for the Trilithic DSP meters.